Hello, everybody. Today we're going to be working on Unit X. And this one is not a unit that relates to topics specifically in our textbook. So you're not going to find a chapter called Chapter X or anything in your book. But I find that this is a really important piece to computer programming that not all programming books cover, I think, at least in the amount of depth that's necessary to understand what you're about to learn. So when we are working with computer programming, the essence of what we're doing is problem solving. Some time ago, some scholars discovered that there's actually, methods for solving problems. It can be scientifically broken down into, define what it is your problem is, and then figure out how to get to your solution. And what these scientists discovered is that there's actually a pattern, and there's 3 techniques for solving any logical problem. And you see I have them listed here. So one way to solve a problem is step by step. So for as silly as it is, I have an assignment in here that's like, give me a recipe, right? And a recipe is a great example of a problem solving approach that's done step by step. So like your first step might be, look, okay, I'm going to make my chocolate chip cookies. Well, the first thing I do is I find all my cookware, right? Get my cookie sheets out, my parchment paper, my mixing bowls, turn the oven on, set it to 350. And then I go through and I look at my ingredients. I grab my eggs, my flour, my chocolate chips, whatever other stuff I'm throwing in there. And then I combine them in a certain way. I put them on a pan a certain way, cook them a certain amount of time, pull them out of the oven, put them on a cooling rack, let them sit for 5 minutes, maybe not, and then start eating those things because they're so delicious, right? But if you listen to like just the simplicity of that, there's an algorithm, there's a sequence to completing those steps. So wait, well, you don't cook the cookies before you mix the ingredients. You mix the ingredients and then you cook the cookies, right? And that's pretty important that you have those in the right order. And that's what happens with computer programming, is we look for those patterns, what makes sense to go first, second, last, or whatever, to actually get the solution to work as you intend. So a lot of times we'll have a vision in our mind on how to make a cookie, and then you sit down and you actually make the cookie and go, oh, I didn't know that I put in the chocolate chips at the end. I thought I put them in with the butter, No, you make the cookie batter first and then you add the chocolate chips, So it's those types of weird little things that we're looking at. So that's an example of one of the 3 methods to solve a problem. The other method is the repetition portion of it. So let me explain what that means. If I was to mow a lawn, so I got my lawnmower fired up and I got this big rectangular space, I would start that lawnmower, and what would you do? Probably you'd find one edge of the lawn and you'd probably go back and forth in some sort of pattern, or maybe you'd go around in a circle and work towards the center or whatever, right? You'd have some sort of a thing. But one thing that you would notice is, well, first I go this way and then I come back. Well, then I go that way again and then I come back. Well, it's the same task. You're just doing it over and over again. So one method to solve the problem is just to repeat a task until something is done, right? So if I'm counting the number of grains of sand on a beach, well, 1, 2, 3. I mean, it's a repeating process. It's not like I'm coming up with something new. So repetition is another way to solve a logical problem. Another thing that we are often confronted with is selection. So let's say I'm making those chocolate chip cookies and I'm like, oh, darn, I don't have any chocolate chips. So I get to the situation where it's like, if I don't have chocolate chips, then what the heck do I do? And the then becomes, well, I have some nuts, I have some raisins, or heck, I got a car, I can just drive up to the store and get some more chocolate chips, right? So sometimes you're presented basically with a fork in the road, and that fork in the road, you'll have to pick one way or the other. And depending on which path you pick, you'll have a different outcome or a different result. And sometimes that can be leveraged to control the outcome of a program. So these are pretty important little things to keep in mind. So any logical problem can be solved with a series of steps with a sequence, repetition of steps, or a selection of steps. And those 3 structures are repeating. Now, the fascinating thing is when we start to actually break down a computer problem, a programming problem, a recipe, if you want to look at that as kind of like an example of writing a computer program, often what we'll do is we'll write down a sort of computer code-like approach to building computer code before we actually write the computer code. So for example, if I was to build a house, I would make a blueprint first with all the measurements I want, you know, what materials I'm using. Am I using 2x4s, 2x6s, drywall, siding, you know, what am I using? And I would then come up with a series of steps. I'm not going to build the frame of the house before I have the foundation. So I would think first, well, get the foundation poured, buy the lumber, you know, build the frame, nail it together, add the drywall, you know, the series of steps that goes with. And I can do that in a verbal sense. And then verbally what ends up happening is we call this pseudocoding. It's not really coding, but it is describing what you're doing to solve the problem. So for example, if I was going to figure out how much you guys pay in income taxes, well, how do I do that? Well, first, I guess I need all your documents, right? Like give me your check stubs or your W-2 or your receipts or whatever, you know, however you do your business. And then let's like put it down and add it all up. Let's subtract your expenses and your costs. And then we can figure out what your net income is. And then we can compare it to the tax table and figure out how much you can pay or you should pay. And then let's look at how much you've paid in already. If you get a regular paycheck, you're already paying in, and maybe you get a refund, and maybe you got to pay a little bit more. But there's a series of steps, and I can describe them verbally and write them out. So that's what we call pseudocoding. We can also expand that and start to do a process called flowcharting. Now, I'm not going to like formally teach you how to flowchart here. In fact, you can do like in a business program. You might have like a half of a course that talks about how to business flowchart. And in having been a business major, believe me, I've been there, you know. So what I'm going to do here, just really, really quick, is I'm going to bring up this this PowerPoint. Now, I will say this is not one I've created. This was created by one of our teachers that teaches at Lakeview High School, believe it or not. But she teaches the same Gateway courses that we teach here. And I liked her PowerPoint, and I just borrow a couple of slides because I think they kind of exemplify what's going on pretty well. I think she did a beautiful job of it. So let's take a look at pseudocode and start looking at the whole concept of like the sequential approach. So if we're going to pseudocode, we typically will have some sort of a statement at the top or the bottom saying that we're starting and stopping. Now that seems kind of silly, right? But at the same time, if you think about, like if you were in a car, let's say you were the Google artificial intelligence that's driving a self-driving car. At some point, you got to tell the thing to stop and go, right? So it's like, okay, Google, take me to the store, right? So start. Right? So we have a start and a stop command. And then we'll have a collection of statements that will indicate what the next step is. The sequence of those steps is important. I can't bake the cookies before I mix the ingredients together, right? So that makes sense. So that's what this would look like. Typically, when you write a computer program, for as simplistic as it seems, and this is often what a computer program consists of. We have some sort of an input, whether it's external data or data that we get from a user. We do some calculations or processing, and then we put something out on the screen. And I want you to notice a pattern here too. We have some input, we'll have some processing, and then we have some output. Right? And that's what we call a systems approach. All right. So she kind of goes through here and she has a kind of like the build up. So you can kind of rifle through the slides yourself, one at a time. All right. So she's got a little example here. It's like, okay, start, put underpants on, put pants on, put shoes on. And usually it goes in that order. Although I've seen people try to do it in other orders and it gets kind of interesting, right? It only works with shorts, right? Or sweatpants. You put your shoes on first. So if we compare it to like computer programming, we might say get the first number, get the second number, add the two numbers, display the result. Just very simplistic. And then she has a little example. All right, it says, try this. Write the pseudocode, a program that gets a dog's age in human years and displays the dog age in dog years, right? And they say that the general rule of thumb is like 1 year for a dog is like 7 years for a human. I don't necessarily believe that. But, you know, that's what they say, you know. So like if you have a 10-year-old dog, it's like they're like a 70-year-old man, you know. So how would you do that? Well, first of all, you'd have to ask, right? You'd have to say, get a dog's age in human years. You say, how old is your dog? Well, he's 5. All right. So where are you getting that from? You're getting that from the user. So the first thing might say start, get dog's age from human. The second step would be what? Multiply that times 7. So you do some processing. The user doesn't see that. It's all happening in the background. It still has to happen though. And then whatever that result is, we grab that and put it up on the screen. So we got an input, processing, and output step by step, and it has to be in that order. Pretty simple, all right? And there's a kind of like the byproduct of that. Giving a repetition example. Now, don't worry about incorporating what the concept of what a computer loop is yet. We're going to get there several weeks down the road. But repetition is a thing that is important for solving a problem, like the lawn mowing example that I gave. So here we start, and then we look to see if a condition is true, we will keep doing it. So do I still have grass to mow? I do. Well, I keep going back and forth, right, until there's no more grass to mow. And then I would stop. All right, so notice they say in pseudocode, the condition is enclosed in parentheses, and we'll learn about while loops. But our condition in this case for the lawn would be, is there still grass left to cut? And the answer to that would be yes, true. Then keep cutting back and forth until it's gone. And then as soon as that becomes false, we stop. That's how repetition would work. And so they give an example. Yeah, and she gets into pretty granular detail with this with her high school students, and I would imagine that she probably uses this slideshow for a whole week worth of instruction. We're usually doing about 10 minutes. So, but the point here isn't to master these concepts now. It's to introduce you to them so you understand kind of where we're going. You know, where am I steering the ship to? This is where we're going to. This is not mastery yet. Okay. So they kind of give you the example here. Finally, and all right, I'm trying to see where she transitions here. So the next one is what we call the selection, and then some people will call it the decision structure. And so we, in this case, would say maybe if there is more grass to cut, you better cut it. Or, you know, if you know, certain thing is true, then we proceed. Otherwise, we do not. Okay. So it says if a person is 18 or older, they are allowed to vote. You know, well, yeah, I guess that's true. But if you're 17, you're not going to do that, right? So the if statement here would be like this. So if person is 18 or older, the statement inside the parentheses, is it true? Then you do what's inside our statement. If not, you just move on. And that's the essence of decision. Now, I'm not going to go into too many more examples here, but all the stuff that you're seeing here in the verbiage is pseudocode. It's not computer code. It's kind of like it. It describes what we're going to do, but it doesn't really detail it. Now, a lot of computer programmers, very frankly, when they start to write a computer program, they do not pseudocode, right? Because it's like, this is pretty simple. I'll just go in there, start typing up some code. No big deal. I'll figure it out. And then they'll learn as they get bigger and bigger projects that if you don't do this step, you're screwed basically, because you have no roadmap to follow on how to get from point A to point B. You have no clear indication. I mean, you might know that you can get in a car and get to California from Wisconsin, right? But there's probably 1,000 different ways to drive there by car, and which one is the best and why. It was really very subjective, you know? So if you have a plan as to which way you're going to go, it's a lot easier to write the code. So I always tell people that as you start to write more and more complex programs, pseudocoding becomes critical, absolutely critical, for putting a program together and having a clear picture as to where you're going. And if you're not doing it, then you're going to find out that you're going to be wasting a lot of time writing code that you probably have to rewrite. So that part of it is good planning makes for less redos later. All right, let's also move on to this concept of flow charting things. She goes into some pretty detailed examples there, and I'm not too worried about those, but you can explore those on your own. Another thing that we do is we will often do some flow charting. And what I'm going to look for here, and if you guys can just bear with me as I kind of fumble through my file system, is I have some examples of flow charting. I just have to find them here. And they come from our old intro to programming class. And I'm trying to find one that, you know, maybe this might be kind of interesting, actually, to see if Google even opens it up for me. There we go. So this is a very primitive thing, and you can see I put this together inside of Google Draw, which is their graphics program attached to the Google Apps Suite. And for a program that is sequential, we typically will list all the steps in a box. And there are right and wrong ways to do this, by the way. This is an example from a student that we used in class. And I wouldn't necessarily say that this is the right way to do it, but it's an example, all right? So let's just look at it just as a starting point. So here it says start program and give instructions. All right, so, okay, so what they were building is a computer program that plays rock, paper, scissors. You guys know that game, right? And everybody always chooses rock for the first one. Paper, I don't know. All right, so then you pick one, and then if it's a tie, you do it again, right? If it's not, then you have to figure out, does paper cover rock, or does rock smash scissors, or does the scissors cut paper? You pick, see who the winner is, and then you say, you want to do it again? Best of 3, best of 5, you know, that kind of thing. And then ultimately the program will stop. So that's a really primitive example of this. But you notice that each step or part of the program, what we might think of as an instruction, is designated in its own little box or shape. And then we also have arrows showing the flow of the steps. Usually it's top to bottom, but every once in a while, you know, if it's a tie, right, what do? You have to go back and you have to pick again, right? And if you play and somebody wins, then you go, you want to play again? Well, then you go back to the beginning, you do it over again. So that's an example of repetition there in a couple of different ways. And also decisions being made. So if it's a tie, we can go back. If not, keep moving. All right, so let me get rid of that one and bring up another example on the screen here, if you guys can bear with me. And this will be kind of a combination of different techniques. And I know that this looks a little complicated to start with, but this one is actually done in a little bit clearer format and with the right shapes for the boxes. And that's kind of an important thing. All right, typically, whenever we start or end a program, those instructions are in a rectangle. That's the format. That's just an instruction saying stop, go, and doesn't require any interaction from the user or any decision or processing to be done. When we move to the next 2 boxes, so this particular thing, well, it says good driver flowchart, but actually this is figuring out how to figure out which number is bigger than another. So the program is actually choose the largest number. Isn't that interesting? So in this program, we would have the user input a number. Now notice the different shape. the box is now a parallelogram. So I don't know if you guys can see my hands, but it, you know, the sides of it shifted a little bit. Top and bottom are horizontal, but the sides are slightly on an angle. That's a parallelogram. And those indicate that we're interacting with the user. So in this case, I'm getting input from the user, asking them for one number, then I'm asking them for another number. So the screen might say, enter a number, and then enter another number. They type it in, press enter. Now the computer software kicks in the background and a decision is made. It says, if the first number is greater than the second number, if that scenario is true, we'll follow this branch. We'll follow the true branch, and then we'll do an output. Now notice the output is in a square box. So it's just going back to the screen. The user's not interacting with it. It's just coming back at them. And we're going to output the first number is larger, right? If that's not true, then we check to see if the two numbers are equal. Because there's three different scenarios here, really, if you're comparing two numbers. One is bigger than the other is bigger than the first, or they're both the same, right? We got to cover all three scenarios. And the one that students usually miss is the one that they're the same. They either go bigger or smaller and call it done. No, not true. You have to look at every scenario. And this is kind of the leap of change that you'll make in your thinking process as you learn how to program, is thinking about that scenario that others might ignore. And frankly, you know what, it takes a little bit of practice to latch onto that. Some people kind of have this sense about them when it comes to working with both mathematics and computer code, that they kind of see it as a piece of music almost. That's like, of course, I mean, of course, we didn't think about that scenario, so it just pops into their head. But I'm going to tell you that most normal people, and I fit into that category, I really had to train myself to think in this way. And it's not an embarrassment to admit that. It's just how humans think. To break a problem down to such a granular level is a new way of thinking for most people. But once you start to see it, then you get comfortable with it, and then you start looking for that granular detail. So in this case, the first number greater than the second, great. But if it's not, there is the possibility that they're the same, right? So if they do happen to be the same, so the next step here is checking to see, are they the same? And if that's true, the output's going to say they're the same. Neither one is bigger, right? Otherwise, if that's not true, we're going to output the second number is larger. So this is really a great little example of which flowcharting shapes to use. You'll notice that whenever a decision needs to be made, it's in the diamond, and then it branches true and false. And then if it's something that's just going on the screen, it's just in a square or rectangle with straight sides. If we're interacting with the user, there's the parallelogram, the slanted sides. And those are really all the shapes that you need for most computer programs, although some people will throw in others. But yes, please.
What program do you recommend to do this process that we're looking at right now?
Robert, that's such a great question. You noticed the first one I showed you was what? It was the Google Drawing program.
Okay.
So that's built into your Google App Suite. You can do it with that one. I often use PowerPoint or Microsoft Word because they have these draw menus and insert menus where you can choose shapes. See the menu there? And guess what they have in there? All the flowcharting shapes are right there.
Okay.
Now,
that's with PowerPoint or
yeah, that's PowerPoint, believe it or not.
Okay.
So you would use PowerPoint to do flowcharting? Well, it works, why not? You know, you're just trying to get the shapes on the screen. You can do the same thing with Microsoft Word though. And, and truth be told, with a lot of different programs will have these shapes built in.
Is out of the two you just mentioned, is there one that's probably more user-friendly, or they're both equal? Or
I'd say they're pretty equivalently useful.
Okay.
You know, if I was to do this on my own, depending on how complex the output is, I would probably just do it in Microsoft Word, frankly. You know, PowerPoint would probably be my second choice. If I was doing it professionally, there is software that you would want to use, and that's called Microsoft Visio, V-I-S-I-O. But that is really a much higher level tool. So it does flow charting, but it's also designed to do network diagrams or floor plan layouts, or like, you know, it's more of a high-end tool. So if you were like a professional flow charter, that's probably what you would use. For the sake of this class, for doing it for like 1 week's worth of homework, don't buy anything special. Just use PowerPoint, Word, or Google Draw, or some other drawing program where you can accomplish this. What I do like about using PowerPoint and Word, though, is because if, let's say I go ahead and insert a shape, so let's say I wanted to put in a square, right? I just draw it, and then I can just start typing inside of it. It's just that easy. You know, not worried about the colors, the fonts, it just works, you know. And for me, for doing a simple little assignment like this, hey, you know, let's do it. You know, go with the simple tool. Don't make it complex when it doesn't need to be.
And one other question, in terms of the different shapes, is that something you're looking for, exactly what you just described, the parallelograms and so forth, having in the different steps you want different shapes?
That would be the ideal, Robert.
Okay.
So like if you paid really close attention to my lecture and took copious notes, and you gave me back exactly shapes like that, and like watched this video and studied how I did it, you know, and some people will do that. But you also notice that the other one, which is a little more free form and not quite so pretty, and the shapes weren't quite right. But you know what? That person still got all the points, because it wasn't really about the shapes. It was understanding what the process is. And that the process of both pseudocoding, writing out the steps, and then creating a visual really, really helps in my mind in figuring out a problem, because you can, you know, having a visual for something, you know, some people are just visual learners. I mean, let me give you an example. There's a follow-up slide here that we're not looking at, and this is actually the good driver problem from our intro to programming class from many years ago. Oh, darn. All right. I just wanted to scroll up on the screen. But what the problem was, it was like a word problem that basically said to the effect of like, this is how insurance companies figure out what your insurance rates are, right? And they try to determine if you're a good driver or not. And they had like a very verbose like paragraph on like what that all means. And how do you figure out how to turn that into computer code? Well, you take the words that were given to you and you start breaking down what is being said, and then creating a visual. So for as simplistic as this is, it does kind of work like this. So did you know that part of your auto insurance rates are based on your personal credit score? A lot of people don't know that. So like if you don't pay your bills and go bankrupt or something, car insurance companies think, well, this person might get in an accident just to collect some money, you know? So let's put the rates up a little bit, because chances are they're going to get into some sort of thing. And if they're not getting into some sort of thing because they're trying to scam us, they're probably more likely to drink, smoke, get in trouble, you know? So they have like these, you know, these patterns. Now, you know, I don't know if that's necessarily fair or not, but you know, that is how they do it. You know, the credit score is part of it. And then they also look at the number of incidents you have, and an incident can be a ticket, an accident, or whatever. And then based on that, you get your things. Now, I know another really big factor in auto insurance rates, for example, is where you live. So like, I live in an urban area in Milwaukee where I have to park on the street, right? And I kid you not, two weekends ago, we had some guy on a drug-fueled rage or something, like in the middle of the night, going through the neighborhood, smashing car windows and knocking over garbage cans. Cops caught him in progress. It was a trip. I don't know what he was on, but because of the zip code I live in, I pay probably like 3 to 4 times the rate of somebody who lives like out in Brookfield.
It's the same here where I live. New Orleans is very high. Louisiana.
Yeah.
Very high.
I'm east side of Milwaukee, you know, I mean, it's about as urban as it gets, you know what I mean? People freak out. They come to my neighborhood and go, this is a bad neighborhood.
Yeah, I've been there before, believe it or not.
So, you know, you take that with a grain of salt, but just to show you that when the problem gets more complex, the flowcharts get more complex. So here's that same auto insurance problem really broken down to even a more granular level. Yeah, I know that's probably hard to read. And that screenshot was actually created with a professional flowcharting program. We used to use this piece of software that would create the flowchart for you. And All right, but now I have this whole tree. So like if I was an insurance agent, I could follow this tree and figure out like what category you fit into and then give you your rate. Now, of course, they have software that does it, but seeing it broken down like this, what all the decision points are, what the outputs are, you know what, this is easy to write code now because my whole problem is all spelled out. Step by step, what all the decisions are, which patterns we're following. And that's really the point of this, folks. So let's go back to the course shell. So once again, what's the essence of computer programming? Problem solving, right? How do we solve problems? Sequence, repetition, and selection. We use pseudocode, plain English statements, flow charting to help create a visual when the problem gets a little more complex. And frankly, if you can apply these techniques to your process of writing more complex programs, and more importantly, solving any problem that really comes before you, you flowchart it out, you pseudocode it. It is a technique for solving the problem. Anybody that works with really complex software has to start with this, otherwise they just cannot even map it out. So often you'll go to like a big IT company, and maybe you've even seen like goofy videos or goofy movies of like, you know, people working at Google or something, and they'll sit there in a room with a whiteboard and they're drawing stuff on the whiteboard. And believe it or not, that's one of the key tools for computer programming when you're starting to design a piece of software, is to go to a whiteboard and kind of figure out where we're going to go, how we're going to tie all this stuff together. They make a map and then they start to code it out. They always have a plan first, then they execute. All right, so let's just do enough of that stuff. That's enough to arm you guys to do these assignments down here. So there's a few of these, and I'm hoping that you take the extra credit opportunity while you have it. And you guys will notice I put a lot of them in my programming classes. And my advice to you is pick up every extra credit opportunity you can, especially when they're easy. Because then when you get to the end of the course and the pressure is on, you got a big project or a final or something, you've built up all this extra credit. So if you skip an assignment or bomb on the final, you're okay. You know, and that's kind of the point of the extra credit. It's kind of a safety net. Scarf it up whenever you can. The other real helpful tip is, if we're at the end of the course and you're like, oh man, I'm going to fall short on points, you can go back to this first unit and grab that extra credit assignment, which is going to be a piece of cake for you at that point, and grab the point. Why not? You know.
Another question.
Yes.
So for this assignment here, the recipe, did you just want us listing in a Word document the steps, or did you want to in the other format we just discussed?
Robert, that's an excellent question. You will notice that I actually say create a Word doc.
Yeah, that's what I did.
But notice there's an or, right? It says or directly within the right submission area of the assignment. Okay. So for example, and you know, I do want to demonstrate this. Arnie, you're new to this. You notice that, and let me just backtrack a step here. So whenever I do my course shells, I always show my assignments. I usually put these flags on there so you know what's an actual assignment. To turn in an assignment, you click on the link, but you should always read the instructions real carefully. I usually have this like green bold text at the top saying, what's our goal here, right? The goal is create pseudocode to describe the steps in creating your favorite meal. So whatever that happens to be. So I read the instructions, think about what your favorite home cooked meal might be, then find a recipe online or from whoever makes this for you. So if your mom makes mac and cheese, get her mac and cheese recipe. And then convert the recipe to verbiage in sequential order. So a recipe by its very nature typically is going to be a sequential series of steps. So I'm not trying to get you to do if statements or loops here. Then create this as a Word document or directly within the right submission, quote unquote, area of the assignment upload. So let's say, okay, I got my recipe here, I'm ready to do it. So I click the link and it brings up the interface. The interface will tell you when it's due. And then it'll also repeat the steps just in case, you know, or the instructions just in case you forgot. And then in this case, I could either create a Word document and attach it, or I could just click this, write submission, see this button here, and I could just type it up. So I could just say, okay, the other night, for the very first time, I made cheese enchiladas for everybody. And actually it turned out pretty good. I was pretty impressed, all right? So I'm gonna call it cheese enchilada recipe. All right. And so usually how does a recipe go? First, usually you list your ingredients. So like most people will list ingredients. So let's just say I'm listing ingredients, list ingredients. Okay, so just to pretend like I did. So tortillas, enchilada sauce, lots of cheese, some onions, a baking pan, whatever. And then my first step might actually be, for a lot of recipes, step one is preheat oven or something like that. You know, preheat oven to 350. All right. Prepare cookie sheet. And the way, and this is just a helpful recipe tip. I used to like butter my cookie sheets to make my cookies, and then I figured out parchment paper is much easier. Parchment paper is like the secret baker's trick. So I put a piece of parchment on there, right? Have it all cut up, oven's all heated up. Then I go ahead and make my batter. So I make the batter, and then I might like beat eggs, mix in flour, mix in butter, you know, whatever the steps are, you know, list them. And I'm being very simplistic here, right? So
I was just asking because I wanted to make sure. I did it last night. I was thinking maybe I had to go back and redo it. I'm sorry. That's why I asked. But I got it now. Yeah.
yeah, and you know, the truth is, you guys, I'm not very persnickety about this, because if you got the words created somehow and I can see what you wrote, you're probably fine. When we get to actually writing computer code and you don't do it right, the code's not going to work, you know, so that's kind of its own like self-determining mechanism. All right, let's say you have it all in there just the way you want it. Then you can just go ahead and hit the submit button. If for some reason you happened to type it up in a Word document, which is fine, you can actually take that document and drag it over and then just drop it into this interface and see how it turns purple. That attaches it to it. If you don't like the drag and drop approach, you can always click browse my computer and go find your file. They have also added this cloud storage button. So if you use like Dropbox, OneDrive, Google Drive, you know, SugarSync, all those like Box, whatever, all those programs, you can actually tie it in here. That's up to you how you proceed. For me, for something like this, it seems to make more sense to just type it up right in this box and be done with it, because it's not really that complicated. Up to you. Also notice that there is a draft button here. So if you're in progress and you get interrupted, hit save draft and you can come back and complete it later. Because once you hit submit, it's submitted to me. But let's just say you screw up and, oh shoot, that wasn't what I wanted. I forgot to put the last thing in there. You can come back and submit again. But to do that, you always have to go back to the original assignment listing and then click on the title again to submit again. And you can submit usually up to 5 times, is usually how I set them. If you find that that's not the case, just email me and I can lift the cap and you can submit more. All right, let's move on to the next little piece here so you're aware. And that is, for that recipe assignment, there's an extra credit piece as well. So the extra credit piece is to create a flow chart for it. All right, this is a piece of cake. In my mind, you just take the words that you typed up step by step and put them in boxes and connect them with arrows, and you just earned another point. So why not, right? I do have another one here at the bottom, and this one is a little bit more of a challenge one because it's going to get you thinking a little bit. And it says create a flow chart. So we're not looking at pseudocode. We prefer the flow chart to match the problem solved in the attached document. So somebody already figured out the steps to solve it. You got to create the flow chart. See the scenario here? It says, read the document carefully as an example of how to solve it. Once complete, create a flow chart, put it into a Word, PowerPoint, Google Draw, or other program, and then save the final version as a Word doc or PowerPoint format, and then upload to Blackboard. So it tells you what to do. Let's take a look at the problem description, just to kind of give you guys a little bit of a preview of this. So once again, this is a problem that has already been solved with pseudocode, but it goes through a whole scenario. So it talks about these people who, you know, work lawn care, And, you know, the guy's job basically is to determine how much fertilizer do I need to buy to put on the lawn. All right, so he says he has to figure out how much liquid fertilizer he must buy for the application on a client's lawn. The client's lawn is rectangular and measures 30 feet by 50. All right, you do the math on that, it comes up to 1,500 square feet. But the instructions in the bottle of fertilizer indicates he needs to buy 1 gallon of fertilizer for each 9 square yards of grass. So we got this problem where our calculation is square feet, but the jug is in square yards, right? And it says to solve this problem, John has to figure out first how to convert square feet to yards. And of course, you can go to Google and type in and you can figure that out. But as computer programmers, we need to figure out how to do that math or with that conversion and write it into computer code ultimately if we were writing this as a program, right? So he also wants to make sure he buys at least enough to cover the lawn. So if he figures out that he needs 3.5 jugs of fertilizer, the problem is he can't go to the store and buy I'll take 3.5 jugs. You know, you have to buy 4, right? So the answer is really 4 for getting, you know, the correct thing. So since he left his phone at home, he can't just look it up on the internet. All right, so it's a little caveat. And but he has a calculator in his truck. He will need to convert from square feet to yards, and then finding a basic formula. So you can go out on the web and find that, but I provide it. It says we know that 3 feet equals a yard, and that a square yard is 3 feet times 3 feet, or 9 square feet. So 1 square yard equals 9 square feet is really the formula. So there it is, right? To simplify this formula so we can enter square feet and yield yards, we need to get rid of the 9 on the right side of the equation by dividing by 9. So if this is like basic math stuff, or you can multiply by 0.1 repeating, and that also gives you the right amount. So here is the pseudocode that solves the problem, all right? And I'm trying to get it all on screen at the same time. So you'll see that we get input from the user, get the length and the width of the lawn. Then in the background, we do the multiplication, all the math. And notice, unlike some of the previous examples, it wasn't like one equation. Sometimes you have a series of equations to get the answer, right? And that's what's happening here. And then it turns out that he needs 18.5 gallons. And he doesn't want to run out. He can't just buy 18 and stretch it. He's got to have at least 18 and a half, so he buys 19. So the answer is 19. Now your job is to take these steps and turn them into a flowchart. It's really not that bad. But the whole point is to get you thinking about the process and the kinds of things that we think about when we write code. And folks, you know, it's not like, see, this is what I love about computer programming. It has nothing to do with the way we feel or think or anything like that. It's all based on tangible, like, facts. Although we are working in virtual environments to create the code that we create has an effect on the physical world. And really the beauty of writing computer code is that we can figure out problems very quickly and simply once we have the process for solving it, and then apply that solution to any scenario. It's just a marvelous thing. And when I think about how far we've come with computer programming and honestly a pretty short period of time historically, and what that's done for us. Computer programs put men on the moon, you know, if you even believe that was real. Some people don't believe that was real. But did you know that NASA a couple of years ago shared the computer code for the navigation system that they used to get to the moon? And it's just fascinating when you go look at that stuff and how people that didn't have all the tools that we have, they had very primitive computer systems, even had the wherewithal to think about doing this stuff. I'm like, oh my God, these people were just brilliant and they had nothing to work with. Here we are, where we have like these smartphones in our hands that are like all the supercomputers on the planet combined from like the 60s and the 70s, and this one like silly little like Samsung device. And what do we do with it? You know, we're on Facebook, Instagram, you know, check out this YouTube. You know, that's what we do with our technology. But rest assured, we can also use it to do some amazing things. And I like to think that by, you know, writing computer code and solving like problems for people, we have the capability of like transforming the world into a much better place than it is. And I'm
I have
really
a question.
Yes, Robert.
The flow chart for this, is it going to be as complex as the one we saw? Is that what we're looking at in
No,
terms of?
not at all, Robert. In fact, this is a series of sequential steps.
Okay.
It'll basically be, and I mean, not to give away the answer, but almost
No,
like taking all these.
yeah, I'm trying to figure out how to do it. Yeah.
Yeah. Oh, and if helpful, next time we get together, we can look at a quick solution for it. It's not a big deal. And I would bet that even at guessing at it, you'll probably get it right. The point here is,
Yeah, I'm probably overthinking it.
you totally are. But you know what? That's not an unhealthy thing for a computer programmer. And then, it's like one of those weird skills. You pick up skills as you kind of go. And I had that same tendency when I was younger. I would look at a computer problem and go, "Oh my God, I'm never going to get this. Oh my God," But keep in mind, when I learned how to computer program, a lot different than what you guys are doing, because I'm gonna demonstrate stuff for you. I video stuff for you. I show you how it's done. I give you links to websites where they show you. When I learned, I would walk into the classroom in the computer science program. We didn't have computers in front of us. Nobody had laptops. We'd sit there with notebooks, and the teacher would write code with chalk on the board. You'd scribble it down in your book, and then you'd run over to the computer lab later, and hopefully you wrote it down right and you could get it to work. You guys are going to be in a much different scenario. So yeah, and there is that tendency to overthink it. And then one of the things that you'll learn, I think, in the process is when to overthink and when not to. Because ultimately, the best computer algorithms and code that we write are the ones that are simple, that accomplish the task with the least amount of steps, right? So like you might watch somebody mow their lawn and go, "Oh my God, that pattern you're using is stupid." I could cut the lawn twice as fast if I just went back and forth as opposed to going in a circle or whatever the case is. But that's what we're learning here, is that the process part of it, I think, more than anything in the problem solving. Anyway, I'm going to go.
One other thing, if we do that flow chart and it's incorrect, you'll let us know and we'll have to redo it, or do we have a chance to redo it if it's not quite right? Or
if it's really that far off, Robert, yeah, I'll say not even close. Let's try again. Okay. I don't anticipate that to be the case, but
okay.
Yeah, I usually do give people the option to fix things. There are some exceptions though. With I have to kind of take it with a grain of salt, because if there is the correct way to do this fertilizer problem, and I do have solved versions of it, there's not really too many deviations. In some cases, people, like if they're writing a computer program, will just start walking the wrong path and keep following it, and it takes them down a dead end. In that case, I kind of steer them back to the right path and then let them finish that path. And once again, Robert, you've had me in class before, so you know that like my grading techniques are not punitive and are not like designed to punish you. It's really designed to show you the right path and get you on that path and learn it. So that's my goal here. All right, this unit, I'm going to call this unit wrapped up. In this video, well, actually, that's not true. I got a couple more things to do here, so I apologize. I just want to let you guys know what my time frame is. I do have a 1 o'clock meeting, so I'm going to say another 20 minutes or so before I have to sign off. And what I'd like to do is talk about these other two items in Unit X. And one says, explore the resources page. So what I'd like to do real quick is, first of all, let's point out where the resources page is. So I have this little auxiliary menu item where I like to put kind of like general course resources. And I like you guys to be aware of the stuff that's there right from the get-go. You'll notice one of the first things right at the top is all the PowerPoint slides for the entire textbook are contained here in the zip file. You will notice that as we go into each unit folder that I also include the chapter PowerPoint with each chapter. Now, when it comes to following the PowerPoints, I will tell you that I only do that for one chapter in this book. So in Unit 1, I follow the PowerPoint because I think he's got some stuff in there that's useful. And then after that, I kind of abandon them and I just lecture my own way. okay? But I provide them for you because, hey, you guys paid for that expensive textbook. You may as well have all the resources that go with. And for some people, looking at a PowerPoint is sometimes a little easier than reading the book, and you can always use them in combination. So just an extra resource for you.
Yeah,
Another
because
thing,
I'd have to compare. Me, I have the second edition thing of the book instead of the third, so I'd have to
you know,
compare.
that's a great point, Arnie. And
Yeah.
and if you do have a version difference, then you can see what the differences are.
Yeah.
Another good thing you should know, Arnie, is that in the subsequent chapters when I'm lecturing, what I do is I do a step through of the chapter as opposed to PowerPoints, like kind of like if you're reading it, but I go through all the examples and show people how stuff works and which parts of the chapter are really important for you guys to know. So any of the chapter examples, so if there's code in the middle of a chapter, that code is all in this zip file that you can download. So you can download it and try it yourself. What's really cool though is if you have the e-version of the book, the e-version of the book allows you to work some of those exercises right inside the book. It's an interactive textbook. And I'll demonstrate that in probably later units as we go. Another thing that's helpful is there's various sections of the book. So the book has always like practice areas, sample code, and then at the end of the chapter, there will be review exercises. Those are not the ones I assign to you, but they are helpful. Honestly, I think a lot of them are really well written and have great examples. And if you want to try those, all the solutions for the review exercises are here. You just follow that link. It will give you all the answers for those. Then there's also a companion website for the book. And so that one you might want to check out. So the people that have created this book allow you to, without login for the most part, access some of the resources like the PowerPoints. There are some things that you do have to sign in for. And that's what the code in the cover of the book is for. If you have the ebook, that's embedded into the ebook. If you have the printed version, you use the code and then it unlocks stuff on the website. Now, what I've done though, just so you know, is most of the stuff you can download from here is already on this page, on the resources page, just to save you the trouble, because I like to have them too. So that's just helpful to know. And especially, you know, like Arnie, if you're in like the second edition of the book, that companion site might be helpful for you to help see what is different, you know. Another really cool, useful resource is this Python site. So Python is an open source coding language. So in other words, it's not owned by like Microsoft or Oracle or somebody like that. It's free to the world. And as a result, they have a website out here that you can go to, and they talk all about the language. They have places where you can download stuff for all sorts of platforms. There's a community here where people answer questions for each other's, examples of how to do certain things. And more importantly, from here, you can actually download all the releases of Python. And just for the record, and this might be the one significant difference, Arnie, between the book we're using and the one that you might be using, is which version of Python is attached. The one that we will be using, Python 3. And it does have, like, if you notice, like, there's like little sub numbers in there. So it's like Python 3.8 point whatever, because they do these little revisions. But basically, we're using Python 3. There is also a Python 2 that's got a big user base, and you want to be really careful in your book that your book's not written around Python 2, because there are some slight differences. But we're using Python 3. So this is just helpful to know that it's out there. Because Python is so popular, there are huge user communities out there that help you find answers to issues that you run into. And I always love those forums. A couple more little pieces here, and I'm not worried about working on these right now. Eventually, I will put in a request. I usually do this week 2 of the semester, is I put in a request for everybody to have what we call both a VDI and a VPN account. And just kind of to make a long story short, what a VDI is it stands for Virtual Desktop Interface. And what that means is the ability to run a Windows machine by remote control that's actually running on a server at Gateway down in Kenosha somewhere that has a complete development environment built into it. Now, the reason we have that available is sometimes we get students, you know, frankly, they have a Chromebook or they have a laptop that cannot run the software. But if they have a laptop that can get on the internet, they can remote control a computer that can do it and get the work done. And that we consider that a safety net. And in order to connect to that, you also need to have a secondary piece of software called VPN. Gateway's in the process of kind of reworking these systems right now. And I never activate those accounts the first week of class because then people get like too fixated on it. It's really a safety net more than anything else. But by week 2, I'll have accounts created for everybody, and then I will demonstrate it and show you what you can do with it. And it's pretty cool. A lot of people that work in advanced enterprise environments or corporate environments often are running everything they do. Like they'll be sitting on a real computer, but they're not really working that computer. They're working a computer that's loaded somewhere else, usually in the cloud, and usually through VDI. The other thing is that you do have access to Microsoft Office as students for free. In fact, I always tell people you can follow my instructions here, but I think it's probably easier just to go to the Gateway website, honestly, and you just type, you know, Office 365 or something like that and search for it. And then you will end up on this page here, and they'll tell you on how to sign up. There's instructions right here. What's really cool about that is you get it for free. You can install it on up to 5 machines, or you can run it through your browser. Don't go out and buy Microsoft Office and pay for it. You know, school, it's there for free. Take it, folks. You know, free is a great price. My favorite price, as a matter of fact. All right, so that's the resources page. Now, I'd like to go back and cover the one last topic before we wrap up. And it looks like our time is going to work out perfectly. We do need to have a piece of software installed to get our work done. And not the work for Unit X, but all the subsequent work beyond that will require this specific tool. Now, I decided when we first got this textbook that I would use the recommendations of the author in terms of what development environment to work with, because that way, if whatever instructions you read in the book matches up exactly with the tool that you're using. But I will tell you that Python can be authored so many different ways with so many different tools, and I'm not going to tell you that you cannot use those tools. So if you wanted to use Visual Studio, if you're a Visual Studio person, or you want to use Notepad++ or Visual Studio Code, and then add and do things at the command line. I get people doing it all sorts of ways. But my recommendation is to follow these instructions that the author provided. Download the piece of software and then install it. And these are a complete set of instructions straight from the author and straight from the publisher. And I'd like you to try doing that on your own. And then if you run into any sort of issues, next time we get together, we can fix it. Or I can always do a one-on-one with you guys. We can do a one-on-one Zoom screen sharing thing and make sure that you're working. Ultimately, when the tool is loaded up, we'll be using the Spider IDE. That's what they call it. Yeah, it's Spider with a Y. And then IDE, this little acronym here. And I'm just going to warn you that's going to be a term that you'll probably get asked on your midterm, I think is where I put it. IDE stands for Integrated Development Environment. And what that means is it creates a setup for us where we can type our code, check it for errors, and see it running all inside the same space. Okay. So now what you guys are seeing, then this is pretty interesting. I'm not worried about the updates right now. But Charles and Arnie, both of you being in the data analytics program, what you're actually seeing here is later on in your program, this is I think from our data analytics 1 course this past spring, we do end up using Python in the higher level courses in that class to actually do data analysis, which is why you're taking it at the foundational level right now. So here's an example of a Python program, a little more advanced than what we're ready for right now. But what this does is it pulls in data from, it's pretty interesting, we actually pull in live weather data from a weather service online, and depending on the name of the city that you type in, it pulls back the weather. So like kind of like what happens on your smartphone, right? Like, so you probably have a screen on your smartphone. It says, what city are you in? If you don't know, you hit the locate button, and then you got your forecast, your temperature, your wind, your humidity. How does that happen? Well, there's these databases online that are published by the National Weather Service and other services like the one you see here. And this Python code has the capability of pulling the data from the external source, pulling it and showing it to us. But this environment here is, and these are, actually, well, here's an example of when we were analyzing COVID-19 data in our data analytics course. And, this is an environment where we can type our code and then see the result. So like one real simple thing when we do get started is we'll create probably a program that just simply does this. This is like the classic first program that every programmer writes in every language, is you just write a program where we tell it to print hello world, right? And then we have the capability then to hit the little button here, and then here's the program running and there's the output. Very, very fancy and impressive, right? But for as simple as that is, this is where we're going to start. But this tool is necessary for doing our work. And I recommend, and especially if you're new to programming, stick with what the author recommends, and then you can follow with me exactly, because that's the tool that I use. You can follow my techniques. And once you get like your legs underneath you and you feel really strong, and then you can start trying other tools, and then you might find that you like those a lot better, and we'll switch. Or maybe you'll still think that this one's fine. But there's no required tool, just recommended. But this is the Spider IDE, so make sure you get that installed by next time. And if you run into any issues with it, contact me and I'll help you, or I'll just do it during our next session. Once we have Spider installed, from there we're going to get into Unit 1 next week, and I'll release this prior to next week's class. But we will be going into Chapter 1. So if you want to start reading ahead, get your IDE installed, get Spider installed, start reading Chapter 1 all the way through. And you know what? I haven't set the due dates in here yet, but I'm going to go ahead. I'm going to release Unit 1 for you guys, just in case you're ambitious. You see how easy it is for me to do that. And you can actually start watching my lecture videos. And at the beginning, okay, so here we are in a coding class, and you're going to start having exercises. So when you get into an actual programming exercise based on the book, the first thing I will do is I will have the exercises from the book copied into a document, because especially at the beginning of the course, I sometimes find that I have people that don't have the book yet. Arnie, I remember when my kids were that young. Can I give you a piece of advice? Hug them all you can, because when they get older, they don't want it. So.
Yeah, that's my niece, actually.
Oh, fantastic. Very cute. All right, but going back to this really quick. So I will always give you that document, and I'll just download it and show it to you. So this is just an output of the actual programs in a description of what you need to do. So just in case you don't have the book, you can read it from here and complete the exercises. And then you want to follow the steps and then turn it in. Now, what's fascinating about the exercises is, they're required on the book, but I will go through for every exercise that I assign you, and I will have a video to show you how to do it. For the first few units, I will have those released right when the unit is released. So in other words, what he's given us the answers, yeah, the only catch is you have to sit there and watch the video to do it, right? To get the answer. But as we start moving through the course, I won't release those exercise videos right away. I'll give you the lecture stuff, and then I'm going to let you try the exercises on your own. And then a couple, 2-3 days before the due date, and as we get through the course, it might even be after the due date, then I'll release the videos, But I won't leave you hanging. You'll always have those videos to show you how it's done. Okay. Now I do get people that are crafty and they start to realize, you know, and I'm not trying to like help you cheat. I'm just trying to, you know, I realize that people are clever and they know that, like, for example, I have all my stuff is already on YouTube. All the answers for all the exercises are already out there. You just have to hunt them down. But it does take time. And just because you're copying it doesn't mean it's going to work. That's the other catch to it. You know, that's a problem with people copying other people's code. But all the stuff is out there on YouTube. It's all closed captioned. It's all step by step. And, you know, if I just kind of fast forward in the video here and hit play, you can see an example of what we do in class. So I explain why I'm doing it, how I'm doing it, how the author may suggest that you do it, but I like to do it a different way because practical is sometimes different than theoretical. And I always like to pepper that in while I do it. So this is a pretty simplistic exercise here, but they do get more complex as we go. But the goal of this class is really to teach you all the major programming structures that you need to know and all the conventions of the Python programming language. Charles and Arnie, since you guys are going into data analytics, and I say this for all data analytics students, you guys then, in the aftermath of this course, will learn higher levels of Python by virtue of other coursework. For people that are in the web program, you get introduced to Python to learn programming concepts, but you also learn Java and C# and JavaScript and all this other stuff that, frankly, you know, as a web programmer might be more important, but Python is really an important foundational language, and what all the stuff that you learn here will transfer conceptually to any programming language that you will subsequently learn. So like one of the things that programmers always say is like, hey, once you got that first language under your belt, all the rest are a piece of cake. It's just like applying the terminology to something else and learning how that language does it. So that's the beauty of computer programming. If you are in the web programming, you're taking this full time, which most of us this summer aren't, but if you were, you would take Python at the same time as Java, at the same time as Web Programming 1, all at once. And that really creates a super solid foundation for programming. And for a lot of people, that's almost enough to go out and get a job, believe it or not. Truth is, though, if you really want to make money in this field, the more advanced your skills are, and more specific your skills are, the more money you're going to make. So I know my video here is playing in the background, and I'm going to stop that now. All right, but that's kind of our roadmap. Make sure you get the stuff done in Unit 0 and X. Move forward to Unit 1, read the first chapter, get that Spider software installed, and then we'll reconvene next week. I'm going to pick a time. I'm thinking that we might start probably more around noon than 11:30, and I hope that's okay for you guys. And if it's not, don't ever feel pressured that you have to be part of this. If you can, it's just a good thing. I will always record them and post them. All right, but otherwise, thank you for being here today, and I will see you guys all next week.
Yeah, next week. Yeah.